Hey there, in this video we are going to talk about Ollama. Now Ollama is an AI tool or a platform that allows you to configure or deploy the language models or AI models locally on your machine, and it also provides you an environment to develop your use cases locally using these language models. Recently, OpenAI has also announced that they have published the two models, GPT-oss 20 billion and GPT-oss 120 billion. Now, these models are available through Ollama, which means you can actually download this GPT model on your machine, configure it through Ollama, and use this Ollama API to build your use cases. In this video, we are going to talk about how to deploy, how to configure Ollama, how to configure these models, and also we are going to develop two use cases. The chatbot kind of a use case. One is like running directly through command prompt, and another one will be having full-fledged GUI where you can select the models and chat with the models through a front end, and that front end will be developed through Streamlit, which is again an open source platform to develop a fast GUI based dashboard for any use cases. So without further ado, let's dive into this session.
LLaMA is a powerful open source platform designed to run the large language models locally on your computer. It is lightweight, user-friendly, and supports a variety of models from Meta, Google, and even now from OpenAI. With LLaMA, you can harness AI capabilities without relying on cloud services, ensuring privacy and flexibility. Now let us talk about the key features of LLaMA. So these are some of the key features of LLaMA. Number one is native GUI support. So Ollama offers intuitive graphical user interface for Mac OS and Windows, simplifying the process of interacting with LLMs. And then, of course, this is the most important, local deployment. So you can run AI models directly on your machines, eliminating the need for constant internet connectivity after setup. And then the model flexibility. So easily pull and switch between various LLMs supported by Ollama. Then offline mode. So once models are downloaded, Ollama operates fully offline. And that is why it is ideal for secure or disconnected environments. And then there are some optional online features as well, like web search and turbo. So web search requires an internet connection to fetch real-time data from internet. And there is another feature called turbo, which is a subscription-based feature to leverage the data center grade hardware for faster responses. So if you want to run your model on some high-end servers, so then it provides you the data center access through some subscription mode. So these are key features of Ollama. Okay, now what all it takes to set up Ollama on your laptop, right? So these are the prerequisites. Number one, you need a computer running Mac OS or Linux or Windows. At least you need 8 GB of RAM to run the smaller models. Then, of course, an internet connection in the beginning, because you need to download Ollama and then you need to download the models. So therefore, during the initial setup, you need the internet connection. You need administrative privilege for software installation on your laptop, and then a terminal or command prompt, and then you get going from there. Okay, now let's do a setup on your laptop. So we will go step by step. So number one is the installation. There are two ways to install. One is you go to this ollama.com/download. When you go to this website, you will find this particular page. And then there are three options. One is the Mac OS, Linux, and Windows. Depending on your operating system, you choose the downloadable option and download the package. Once the package is downloaded, then just try to follow the instruction and then try to install it. You can also download it through this curl command for Mac and Linux. In either way, the number one step is to download and then complete the setup. And then once your setup is done, then you can check whether your Ollama is running or not. Now, to check whether Ollama is running or not, there are two ways. One is in browser and one is on terminal. Now on browser, you need to access this URL http://localhost and then 11434. 11434 is the default port on which Ollama runs. Other way to check is through the terminal. So on the terminal, you can just type Ollama and -h. -h is the help option. And if this command returns the help option, then you can then assume that your Ollama is running. Now let me show you these two options to let you know like how you can make sure that your Ollama setup is running or not. So here we are on the browser, and if I just type this on my browser, the local host and the port 11434, you can see it is saying Ollama is running. That means your Ollama is running. Other way to check is through the terminal. So open a terminal and then you can just type Ollama -h and then it gives you this help options or the commands which are available in Ollama, and then that is good enough indication that your Ollama setup is now running. You can also check like what are all the models already deployed on your Ollama setup. So because I have already deployed some models, so I can check that. So you can just give Ollama and then list. So it will list all the models which are already deployed on your local setup on the local laptop. Now here I can see on my Ollama setup, I have LLaMA 3.2 and then the GPT-oss 20 billion and Quinn 3 4 billion. These are the three models which are already downloaded on Ollama. All right, so once your setup is complete and once you know that your Ollama is running, then you can download the models depending on your requirement. Now, these are the models you can see. You can just download any of these models and then, try to start with your proof of concepts. All right, so once your Ollama setup is done, then you can just launch the application, Ollama application on your laptop. Now, let me show you how to launch it. All right, so on your laptop, you should try to locate the Ollama icon. Now here I can see my Ollama is here. So you can just do open Ollama. Then it opens the Ollama app. Now in Ollama app, you can see that, these are the models list which Ollama supports. And then you have also seen there are models which I have already downloaded, which you can also, check from the backend directly on the terminal. Nevertheless, when you are launching this application, even if your models are not deployed, then you can choose the corresponding model and then you should ask a question. So say, what is the capital of India, right? Now, you see this model was not there, not downloaded on my setup, and therefore it is first trying to download the model. So what I try to explain you is that even if your model is not downloaded, you don't have to worry about. You just first create your setup, then launch this application, and through application you can download the models which you require for your proof of concepts. Okay, so that is the purpose of demonstrating that you choose the model from here and then you try to run some query. This Ollama app will try to find the model in the backend, and if the model is not available, it will download it from the source. And once the model is downloaded, then you can disconnect from the internet and everything is now locally available for you to experiment your proof of concepts. All right, I'm going to stop this because I don't want to download this model. I already have a downloaded model which I can just demonstrate. So say I have downloaded this model already. So I'll choose that model and then I'll ask, what is the capital of India? And then it says the capital of India is New Delhi. So it has used the pre-trained knowledge to answer this user question. Great. So far we downloaded the Ollama package, we installed, and then we launched the Ollama app. Through Ollama app, we downloaded the model, and now we are able to run the query. So we are able to send the user prompt and Ollama is able to respond based on the pre-trained knowledge. Now, if you see, there are these two options as well here. One is toggle with web search and the another one is turbo. Now, what exactly is these two features? Okay, so let me explain this to you. This web search mode is used when you need real-time data. So first you need to enable an internet connection, and then activate web search mode. So here, let's say if I want to search something, say who won India England last test match. Now I know that maybe the model which I'm using may not have this information, this latest information in the pre-trained knowledge. So then I can just do the just select this web search mode, and then I need to make sure my internet connection is on, and then I just search this. And then you see here now it is searching the web, and then it finds that India versus England 5th test day 5 highlights. So Mohammad Siraj snaps up 9 wickets as India beat England by 6 runs to tie series 2-2. So this tool you can use if you need the latest data from internet. Now the second one, which is the Turbo. Now it is a subscription based mode. Okay. Now for faster response, so suppose you need to have a bigger model, or your use case demands more powerful hardware and not just that the laptop is not good enough, then you can use this subscription based turbo mode where Ollama provides you a data center grade hardware where you can deploy your model there and then use it from there. So that is the purpose of this turbo. But for this, you need to actually create an account in Ollama, and then only this feature will be enabled, and there are some subscription charges as well. All right. Now let us see some troubleshooting steps, because when you try to create this setup, you may encounter some issues, mainly like these three: model fails to load, no response in offline mode, or performance issues. Now, when model fails to load, you need to ensure that you have enough disk space and RAM, that is mentioned in the prerequisite. Then you need to verify that the model which you are trying to download is listed in the Ollama app. So when you launch the Ollama app, I just showed you that there is a list of models which are supported by Ollama. So you need to make sure that the model which you are trying to download is part of that list. Then if you are experiencing no response in offline mode, or anything, any other issue in that offline scenario, then you need to confirm few things. Number one is that the model is downloaded and selected, so that you can check either from the front end or even in the back end. If you go and just do Ollama and then list, then it will list the models. Then you can see if the model is downloaded or not downloaded, right? Then other thing is that you need to also check if you have selected the web search mode. Then in that case, you need to make sure that your internet connection is on. Okay, so that is another reason your response may not come in offline mode. Now on the performance issue, you can do a couple of things. One is reduce model size or choose background applications. Okay, and then for advanced user, you can consider optimizing your system swap memory or upgrading hardware. So that is another things which you need to take care of, and then you can explore the other possibilities if you are struggling with the performance issues. Okay, all right. Now we saw the Ollama app running, and we were able to send the query or the user prompt, and Ollama was able to provide the response based on the model we have selected. Now let us try to build an application using Ollama library and the offline mode, and the LLM is deployed on your local machine. Let us try to write a Python program to build a simple chatbot applications. Okay. Now here, this import Ollama. This imports the Ollama Python library, which provides an interface to interact with Ollama's API for running LLM locally. The Ollama library allows you to send messages to models which you have selected or downloaded, and then it retrieves their responses. Assuming the Ollama server is running on localhost and on the port 11434, that is the assumption. Then we have defined a function which is chat with Ollama. Now, this particular function handles the chat interaction with the specified Ollama model. Now, if you see in the parameter, it is accepting a model name, right? So whenever we are going to call this chat with Ollama function, we're going to pass the model. The default model hard-coded is LLaMA 3.2. Then, of course, there is this print statement. It displays a message indicating which model is being used and instructs the user to type or quit or exit the chat loop. Then there is a Python list defined, which is conversation_history. It initializes an empty list to store the sequence of users and the LLM responses. This maintains the context for multi-turn conversations so that the LLM benefits from this historical information when answering the subsequent questions. Okay, that is the main purpose of maintaining this conversation history. Then there is this while loop. So if you see this while loop, right, so it has different parts. Let us try to first understand what exactly this while loop does, and then we'll go inside this loop to understand. So this while loop creates an infinite loop to keep the chat session active until user types quit. Okay, then there is this user input. So this user input actually it actually prompts the user to enter a message prefixed with something called u. Okay, so then the input, when it is collected from the user, is stored in this user_input variable, right? And as I said, if user types quit, then this while loop will break and the application stops. Then there is this append function. So this append user message, this adds the user input. So this is nothing but a user prompt. Okay, if you see, it is nothing but a user prompt. So where you have role, the user, and the content is nothing but the user input, right? So this adds the user input, which is a user prompt, to conversation history as a dictionary with this two keys, role and the user, which indicates is a user prompt. All right, now we have this try block. Okay, now this try block wraps the API call in a try except block to handle potential errors. For example, if there is a server not running or model not found, then those errors will be caught and the respective message will be displayed. Inside this try block, you see we are calling this Ollama.chat. So this is the chat API from Ollama. Here in this chat API, we need to pass the model name, and then we need to pass the system prompt and the user prompt that we are storing in the conversation history. So that we will be passing here. Once the response is available, we are just extracting the response here. Now AI_response is containing the response received from the model, and that response is then displayed to the user, and whatever is the response coming out of the model is then further appended in the conversation history to make that history maintained, so that in the next question the entire history will be sent to the model to maintain the context of the overall conversation. And then this is the exception handling. So this one will catches any errors during the API call. So whatever error will be coming out of this block will be caught and displayed over here. And then here in the main, we're just calling that chat with Ollama function, which we defined above. And here we are passing the GPT-oss 20 billion model coming from OpenAI. Now let me try to execute this chatbot. So here I have this test.py. So what I can do, I'll just type Python and test.py, and then it will prompt me a prompt. It is saying you, that is the user prompt. Here I can just send any message. So then I can say, what is the capital of India? And then it will take this user input, and then it is going to use this GPT-oss 20 billion model, which is available on my laptop. And then it is going to get the response, and the response will be displayed back to the user. Okay, so it took some time, but then it came up with this response, the AI response that says the capital of India is New Delhi. All right, and if you want to just exit from here, so you just type quit, and then you come out of this chatbot. All right, now you need to create the setup before you actually start executing. Now to create the setup, I will share the link in the description, and also I will talk about it towards end of this session, like how to create the environment before you execute this particular chatbot. So that I will be talking about towards end of this session. Now, the chatbot which we just saw was a very basic kind of an hello world chatbot where there was no front end, no GUI. Now we are going to add a GUI on that chatbot. So we are going to use the Streamlit application. Streamlit is an open source a framework which provides you to quickly develop a front end for your application. So let me explain you the code, and then I will execute and then give you a quick demo for this chatbot. All right. So this is an Streamlit based chatbot application. It is nothing but the same chatbot, but now we have added a front end or the graphical user interface. Now, let me first explain you the code, and then I will try to run that application. Now, this import Streamlit as ST. So this will import the Streamlit library. Now, before we actually even import this library, we all know that we need to, install this library. So that we will be talking about when we talk about how to create this setup. But right now, I'm just trying to explain you the piece of code. So we will be, importing these two libraries, and then this chat with Ollama, right, is the function. Now, this function is similar to the original in the last script when we saw there was a function which we wrote to, provide you the kind of a simple chatbot application. Now, you can just imagine this extension of that particular function. It handles the sending user input and the conversation history to Ollama model and returns the AI response. Okay. The only difference between this function and the previous one is that in here we are actually now trying to also incorporate the front end or the GUI. So you see this part is same. So we have this a conversation underscore history to maintain the user input and the model response. And then we have this try block. In the try block, we are going to call this ollama.chat is the API from Ollama, is a chat API. And there we are going to pass the model and the conversation history, and then we are going to retrieve the response. And whatever response we'll be retrieving will be then adding back to the conversation history. So far, so good. Only thing is then now this particular function is returning is the AI response as well as the conversation history. Now it is returning this because it has to be displayed on the front end. Okay, and that is why it is returning the AI response and the conversation history. Now, here you see, now we are setting up the front end, which is the Streamlit application or the GUI. So here we are, setting the title of our GUI. So this sets the name, or you can say the title and the description. So we are saying the title of the app is Ollama chat app, and in the description it will say that interact with a local Ollama model, select a model and start chatting. So that is the message we are going to display on our front end. All right, once the initial GUI setup is done, then this is the core of the logic where you have this st.session_state. Now in Streamlit, the session underscore state is used to persist the variable across the session. So because when user will be interacting on the dashboard, user will be sending some user prompt and the model will be responding, that will be displayed on the screen, and then user will ask the follow-up question. So on every interaction, how Streamlit works is that actually it reruns the entire script from top to bottom, and therefore if we have to maintain something for that particular session, we have to then maintain it inside this session underscore state, so that that variable is maintained across the session. So therefore this conversation history which we are going to persist for that session is now being added in the session underscore state. So therefore the conversation history is added, and also the model name is added, because once the model is selected for that session, unless user changes the model has to be the same, and therefore we are also adding the model name into this session underscore state. Now here you have this select box, that means we are providing an input selection or the drop-down box to the user. In that drop-down box, we are going to list these many models. You can add additional models. If you have that model deployed, then you can add those models. Make sure that whatever model you are adding is deployed already in the backend. And then whatever model you will configure here will be listed as a drop-down box to the user, and then user will select a model from this list. Okay, so that is about the model selection drop-down feature, which we are going to give on the front end. And then there will be a text box. So on the text box, user will be writing the user prompt or the user query. And then there will be a send button. So when user selects the model and types the query, then user can just hit the send button. And then this send button will actually submit the user query to the backend. And then once the response is received from the model, then update the conversation history. So you need to just add that response in the conversation history. So here, whatever response we are going to get from this function. So you remember this function is returning two things. One is the AI response, and it is also returning the conversation history, right? So if you see here, it is returning the AI response and the conversation history. So we just need to get those two things. So AI response will contain the response, and in the conversation history, we will be just adding the conversation history returned by the model. All right. And then we have the display conversation history. So on the front end, we are also providing a section to actually provide all the conversation history so that we can see how the conversation flow happened. So for that, there is a subheader conversation. So we are adding a section with the subheader conversation, and in that conversation section, we are just going to read all the messages from the conversation history. So this for loop will read each and every messages, and then it will check the role, and based on the role, whether it is the AI, whether it is a user message or the AI message, it will then just display this as a markdown on the dashboard. And then there is a button which is the clear conversation. So in case, let's say you want to start a fresh session, then you can just click on the clear conversation. It will erase all the previous conversation. It will create this conversation history blank, and then it will start the fresh conversation. Now let me run this application and show you how this front end looks like. So to run this application, you need to type Streamlit run, and the name of this file is app.py. Now, when you run this application, it starts an Streamlit application on the local host. So here you see now it has started. So this is the application which is running on the port 8501. And here you see these are the models which I have configured in the application. So remember, this is the title which we gave and the description of the application which we wrote in the backend. Then it provided the model selection feature as a drop-down. So you can select any model. So let's say I select this model, and then you can type your message. So say I type, let's say, what is the capital of India? And then I click on the send button. Then the query is sent back to the model. The model will generate the response, and then this application will then display that response back to the user. And as I said earlier, it will also maintain a conversation history. So here you see, now this is the response it got. The capital of India is New Delhi, and it has started creating a conversation history here. So the first question was, what is the capital of India? And the response is, the capital of India is New Delhi, right? And if you want to, clear the conversation, then you can click on this clear button. So it will erase all the previous conversation, and you can start fresh. All right. So this was about building your own chatbot using Streamlit frontend and Ollama. Now everything is on your local machine. That is the most important thing. Nothing is going outside of your laptop. Your model is deployed locally, and your application is running locally. All right. Now that was all about this Ollama setup, like how to create the setup and how to build a simple chatbot application. Now The code and the guide or the README or the installation guide is available on my GitHub repos. When you go to the GitHub Data Science Champion, and inside that, this 0 to hero in NLP, LLM, GenAI, you will find a folder called Ollama. You need to go inside this Ollama folder, and you will find these packages. One is this app.py, which is the Streamlit application. Test.py is the first application where we don't have the front end, just a backend application. And how to create this setup, you can just go through this README file, and it guides you like how to create the whole setup and how to also create the setup for your use cases, the two use cases which we have just developed and executed. So follow this installation guide and just try to create the setup and run those applications. All the best.